Your task is to migrate the core platform from AngularJS to modern Angular. Oh, and the engineering team is about to grow from 30 to 500 people in the next 12 months. That was the mandate. It wasn't just a framework migration. It was a structural rebuild of a platform that was the heartbeat of the product. I didn't start this migration from the beginning. I joined in the middle of it, and that made everything harder and more instructive. When you inherit a legacy frontend, you aren't just inheriting code, you are inheriting a time capsule. In our case, the business logic wasn't documented in a wiki or a Jira ticket. It was buried in 1,000-line components and scattered across undocumented services. The real documentation lived in the heads of developers who were already planning their exits. The platform was already in motion. The app was broken into several sub-apps, all living in different repos. One team was writing new features in Angular, another was still maintaining the AngularJS app. They were duplicating UI components, duplicating business logic, and slowly drifting apart in ways nobody had formally acknowledged. There were separate repositories for what should have been the same product. The situation wasn't anyone's fault. It was the natural result of moving fast without a shared structural agreement. The first challenge wasn't writing new code. It was understanding the old. The first thing you learn when you walk into a migration mid-flight is that the existing code is documentation. Not good documentation, but honest documentation. It tells you what decisions were made under pressure, what was copy-pasted because there wasn't time to do it properly, and what the team actually understood versus what they thought they understood. Walking into the legacy codebase was like opening a crime scene. Because of the tutorial trap, the tendency to put everything where it is easiest to reach, the codebase had grown organically and dangerously. Developers had fetched APIs directly inside components, performed complex data transformations in the UI layer, coupled business rules to specific framework versions and UI components that were rebuilt from scratch every time a new app was started, rather than shared. The duplication wasn't laziness. It was the predictable outcome of separate repositories with no shared boundary. When there's no clear place for something to live, it gets reinvented wherever it's needed. We spent weeks mapping the system's functionality, trying to separate what the app did from how it looked. We had to identify the core domains and mapping out the functionality. We realized quickly that if we simply ported these components to Angular, we would just be migrating our technical debt to a newer version of the same problem. Splitting a product across multiple repositories feels like autonomy. In practice, it's fragmentation. When I joined, the Angular team and the AngularJS team were building the same UI patterns independently. Product cards, form inputs, data tables, implemented twice, diverging slowly, with no mechanism to keep them in sync. Every time design made a decision, it had to be applied in two places. Sometimes it was, often it wasn't. The obvious answer was a monorepo. One place for shared libraries, one place for domain logic, one place for the design system. But a monorepo isn't just a technical migration, it's an organizational one. You're asking teams that have been working independently to agree on shared boundaries. That negotiation is harder than the tooling. The repository structure was the first thing encoding the wrong architecture, before a single line of business logic was written. We also had a CLI tool. The CLI shared domain logic with the web apps, product data processing, content validation rules, transformation utilities. That logic lived inside Angular services. You couldn't import an Angular service into a Node CLI without pulling in the entire framework. So the CLI had its own copy. Extracting the domain layer into pure TypeScript wasn't just good architecture. It was the only way to share code with something that doesn't run in a browser. That's the moment clean architecture stops being theory. When you have the same rule running in 3 different runtimes without modification, That's when you feel what the pattern is actually for. We needed a shared UI layer. The duplication of components across apps was unsustainable. And with the team growing, it was going to get worse. The instinct is to build your own, a custom component library designed exactly for your product. The problem is that building a production quality design system from scratch is a full team's worth of work. Accessibility, theming, browser compatibility, documentation, and ongoing maintenance. We didn't have those resources, and we shouldn't have pretended otherwise. Instead, we built on top of an existing web component library with a custom theme applied. Web components were the right call here, because they're framework agnostic by nature. The same component worked in Angular, in AngularJS, and in any future stack we might move to. We weren't betting the design system on a framework that might release a breaking change in 6 months. The lesson isn't don't build your own design system. It's be honest about what you can sustain. A thin theme layer on top of a solid open source foundation ships in weeks. A bespoke component library ships in a year if you're lucky. Clean architecture is one of those concepts that sounds convincing in a conference talk and frustrating in a pull request. Layers, dependencies, use cases. It reads like theory until you hit a specific kind of problem. For us, the proof came during the AngularJS to Angular migration itself. When the same logic lived in the domain layer, migration was mechanical. Update the Angular adapter. Update the AngularJS adapter. The domain function didn't change at all. What changed is that we wrote the code only once and just connected the appropriate adapters depending on which framework it was used. The hardest part of this migration wasn't technical. It was getting people to agree on how to work together. Two teams, different stacks, different velocities, and a code base that was already pulling them apart. Proposing shared libraries and a monorepo meant asking both teams to accept constraints on their autonomy for the benefit of the product as a whole. Some engineers saw it immediately. Others pushed back, understandably. You're asking people to slow down in the short term to go faster later, and that's a hard sell when there are deadlines. The architecture only works if the people ship it. You can design the cleanest domain layer in the world and have it ignored within 3 months if the team doesn't understand why it exists or feel ownership of it. Getting buy-in wasn't a single meeting. It was explaining the same reasoning in code reviews, in design sessions, in conversations with engineering managers who needed to justify the investment to product. It was making the benefits visible as early as possible, showing that a domain function was testable in isolation, that a shared component worked in both apps, that a CLI could import business logic without ceremony. Architecture that's explained once and then enforced by process fails. Architecture that's explained through working examples gets adopted. This approach carries real costs. More files, more layers, more upfront discipline. On a small project with a stable team and simple requirements, it's overhead you don't need. But if your codebase is going to grow, if a team is going to expand, if your API is bound to evolve, or if you ever want tests that run in milliseconds, the question isn't whether you need architecture. The question is when you will end up paying for not having it. Thanks for watching, and if you like this content, share, like, subscribe, and see you in the next video.